All right, y'all. So this is going to pick up after the last problems we did in 8-4 were where they gave me zeros and I had to find the other zeros. And the main point was that our imaginary zeros and our radical zeros always came in conjugate pairs. Alrighty, so starting at about number 12 on here. They're going to give us a zero and they want us to find the other zeros. So the polynomial has the given zero. Then they say find the other zeros. So our polynomial, let's see, y'all, the polynomial is f of x equals x to the third plus 3x squared minus 5x minus 15. Now, the zero they're giving us is -3. So remember, since this is a 3 as my highest exponent, we got to get 3 zeros out of this. Now they're giving us one of them. So what you want to do, start with this x to the third. We're going to divide out the zero they gave us. At that point, we'll have 3 numbers left for our quotient. Those we'll use and solve using the quadratic formula or square roots or factoring, whichever we can use. So first, we'll start with our coefficients. So let's see, we got a 1 for the x to the third, 3 for the x squared term, -5 for the x term, and then -15 for the constant number term. So nothing's missing, so I didn't need any zeros. All right, remember, that's going to be my remainder. Now, since they told me -3 was a zero of this polynomial, we know we better get a zero remainder here. All right, so you got to keep doing synthetic division until you got 3 numbers right here for your quotient, okay? So we will bring the 1 down, and then we're just going to start multiplying and adding. 1 times -3 is -3. 3 and -3 give me a 0. 0 times -3 is 0. -5 plus 0 is -5. And then that -5 times -3 is a positive 15. And y'all, -15 and 15 give me a remainder of 0. So let's see what these numbers mean. Remember, these are the coefficients of the new polynomial, and it's 1 degree less than the original. So since that was the x to the third, this is going to be 1x squared plus 0x minus 5. All right, so I don't have to put the x in the middle because it was a 0. So now we got an x squared. We're going to set this equal to 0 and solve it. Once we get down to the x squareds, we're either going to solve them by square roots, which is what I'm going to do to this one. Or if I had the x squared, the x, and a number, I would probably use the quadratic formula. But y'all, square roots are pretty quick because all you got to do is get the x squared by itself. And then the number we're going to move over by adding. So I get my x squared equals 5. Now that my x squared is by itself, I can square root both sides. Now, since I'm using a square root of a number, I'm going to do my plus or minus. All right, so the square root of x squared, those cancel, leaving the x. And y'all, this will be a plus or minus. And guess what? We cannot simplify that square root of 5. So we'll leave that as a square root of 5. So on their answers, they'll say the other zeros are blank. We don't put in the -3 because they gave that to us. We just put in these two, which would be a square root of 5 and a negative square root of 5. Now, MATLAB will let you do the plus or minus square root of 5 for your answer, okay? All right, so notice, they gave me 1. I found the other 2 for a total of 3 zeros. So now we'll do one with an x4 in it. So since it's got an x4, we will do synthetic division twice. And then we'll be able to do our square root or our quadratic formula. So the same thing on this one, y'all. We got a f of x equals x to the 4th plus 16x squared minus 225. And then they're giving me my 0. They're saying, hey, 5i is a 0. So y'all, this would be like number 12 on the homework. And this one will be like your number 13. All right, so they're telling me 5i is a 0, so that's going to be my first C I use over here, 5i. Now, y'all, we got to write out our coefficients. Now, notice I got my x4 term, which is a 1. There's not an x3 term, so since there's not an x3 term, I'm going to put a 0. The x squared term has a 16. There's not an x term, so I'm going to put a 0 for the x term. And then the constant number is a negative 225. So, a little trick to tell you how many numbers you need. If you add 1 to the highest exponent, that'd give me 5. I needed 5 numbers. Up here, if you add 1 to the highest exponent, you get 4. So I had 4 numbers, okay? All right, y'all, so let's get this one ready to roll. So remember, 5i, since it's a 0, I got to get a 0 remainder. All right, y'all, so I bring down to 1. And then 1 times 5i is 5i. 0 plus 5i is 5i. Now, here's where you got to watch out. 5i times 5i is a negative 25i squared. But y'all remember, I squared equals negative 1. So that negative 25i squared becomes a positive 25. Okay? And you can multiply that on your calculator. 5i times 5i, and it'll give you a positive 25. Oh, I meant negative 25, right? Because 5i times 5i is 25. So let me show you. 5i times 5i is 25i squared. But remember, the I squared is negative 1, so that makes that a negative 25. All righty. Negative 25 and 16 give us a negative 9. All right, y'all, negative 9 times 5i is a negative 45i. Added to 0 is a negative 45i. And this negative 45i times 5i is a negative 225i squared. But remember, I squared equals -1, so that's going to make this a positive 225. And y'all, you can multiply the I stuff on your calculator, okay? But notice, -225 plus 225 gives me a 0 remainder. Now notice, I still got 4 numbers under here. So I need to use these 4 numbers. So write down to 1, 5i, -9, -45i. Draw your box. So we got to keep doing it until we get the 3 numbers here, just like I did up here. So if you got an exit of 4, you're going to have to do the synthetic division twice. So y'all, here's the question. They gave me 5i, and I ran it through my synthetic division, got a 0 remainder. What I need to know is, what's another 0 I can check? And this would have had to do with them last problems you did from the homework, like number 10 and 11. If 5i is a 0, then what has to be a 0 also?
Say it again.
If 5i is a 0 of a polynomial, what else must be a 0?
Wouldn't it be -5i?
-5i. Let's see. Reed and Faith, both of y'all got that right. Good job. So we got to try -5i. So in a way, they're giving you 2 zeros, but you got to know that these come in conjugates, okay? All right, so if we're right, we better get a 0 here. So y'all, let's bring down our 1. 1 times -5i is a -5i. 5i and -5i give us a 0. 0 times -5i is 0. All right, y'all, -9 and 0 is -9. So now that -9 times -5i is a positive 45i. So we did get a 0 remainder. So now we're down to 3 numbers. We can do our quadratic stuff. So this is like, now remember, this started with an x4. These 3 coefficients were x cubed, x squared, x, and my number. These 3 will be a x squared, x, and my number. So I got 1x squared, 0 x's, minus my 9. I can now set that equal to 0 and get my last 2 zeros. And y'all, since I got an x squared in a number, I'm going to do the same thing I did up here. Solve it by square roots. So we would start out by adding 9. So that brings down my x squared equals, what, a positive 9. And then we'll do our square roots. So that'll be a plus or minus square root of 9. So y'all, let's see. That's going to give me what? A x equals a plus or minus. In this one, we can actually take the square root and get our 3. All right, there you go. Good job, Samantha. Now, remember, all they want were the remaining zeros. Now, we can't use 5i. They gave us that one, so we got to do the other 3, which were our -5i, 3, and -3. But y'all, once again, in MathLab, you can put -5i, comma, plus or minus 3. It will take that also, okay? All right, y'all, let me let one in real quick. Oh, y'all must be getting knocked off some of you, because... All righty. So, on your homework, if you haven't done your homework yet, I'm going to skip 14 and 15. So what you'll do, skip 14 and 15, because I'll go through the homework later, and I'm going to give everybody credit on those. That stuff you had to do before we had calculators and stuff, and it's a long process on how to find numbers that you can use for your zeros. But y'all, we all got our TI-84s now, so we're not doing that old school stuff. So skip 14 and 15, and I'll give you credit for those. So this problem I'm about to do will be like number 16. So then let's see, the last three were 16, 17, and 18, and they're all doing the same thing. They're going to say, find the rational zeros and then the other zeros of the polynomial. All right, so my polynomial is f of x equals x to the third minus 133x plus 132. And then for part B, they want us to factor into linear factors. And that's just putting them back into parentheses. So that part's not bad. What we got to figure out is how to find our zeros. So there's going to be 3 zeros because that's the x to the third, okay? Now I'm going to show you a way to find at least 1 0 on these. And that's using our graphing calculator. I'm going to graph this, and we're looking for x-intercepts. So we're going to look for x-intercepts on the graph. So if I can find x-intercepts, then I got zeros I can start using for my polynomial, okay? So let me share my graph, and I'm going to plug this into y1. All right, so I had x to the third. All right, arrow back down. Minus 133x plus 132. So I'm going to look at the graph real quick and see if I can find a spot where it might be crossing over that x-axis. And y'all look, it's crossing right there. It looks like at 1, but if I want to be sure, I can go to my table. So if I go second graph to my table, and let me find where the x was 1 at. So look at that. When x is 1, y is 0. So that's giving me my first 0 to try, which is 1. So we're going to go back and do our synthetic division. So we're going to try that 1 first. Now let's write out our numbers. I got 1 for the x cubed. I don't have an x squared here, so I need a 0. My x term is negative 133. And then my constant number is a 132. Y'all remember, that's an x to the 3, so if you add 1, that's 4 numbers. So what we'll do, these 3 numbers that we got left under here, we can do our quadratic stuff too. All right, y'all, bring down to 1. 1 times 1 is 1. 0 plus 1 is 1. One times 1 is 1. Negative 133 and 1 is a negative 132. Negative 132 times 1 is a negative 132. So that's going to give me a 0 remainder, which means 1 is definitely a 0. Now, these 3 numbers, we can do our quadratic stuff. So 1 degree less than an x third means that's 1x squared plus 1x minus 132. All this will now be equal to 0. All right, y'all, so this one will factor if you want to. Now, I'll show you another trick. I know this one will factor, but if you want to check this one right here and see if we can find the 2 answers, let's graph that. So I'm going to go back to my calculator and graph the x squared plus x minus 132. So I'm going to clear this one out. X squared plus x minus 132. So I can now graph this one and see if I can look for some x and y intercepts. So I'm going to hit graph. Now, do y'all see how I don't see anything? Let me show you a trick. I'm going to go to zoom, and I'm going to arrow down until I get zoom fit. Zoom fit, when I hit enter, you can see it's now crossing 2 places on my x-axis. One's on the negative side and one's on the positive side. So if we will go to our table, now watch, these negative numbers are getting smaller and smaller. I'm looking for a 0 for that y, and right there it is. So they want me to try negative 12. Now the other one was on the positive side, so let's arrow down and go to the positive side. And I get a 0 when x is 11. So those would be my last 2 zeros. So look, the calculator gave me negative 12 and 11. But y'all, on this one, I'm going to show you that you could factor this. So x squared would be an x and an x. So everybody's number 16 will factor, okay? Now watch what I do. That last number is negative. Anytime the last number is negative, one factor will be positive, one factor will be negative. Also, listen for the second thing that negative tells me to do. That negative tells me to find factors of 132 that'll subtract and get 1. So factors of 132 that subtract to get 1. Because remember, that's like a 1x in the middle. So you always find factors of the last number that equal the middle number. If that's minus, they subtract. If that's plus, they would add. Now, if you're weak on factors of 132, let me show you a trick. We got a calculator. So let me share my calculator. So y'all, I'm going to go to y equals. If I want factors of 132, I'm going to do 132 divided by x. So by doing that, I'm going to look at my table now. I'm going to go to second graph and go to my table. And let me go up here. The smallest factor's got to be a 1, because see, if I go to 0, I get an error. So 1 and 132 are factors. 2 and 66 is a factor. 3 and 44. 4 and 33. Now I can't use the decimals. 6 and 22. 11 and 12. And then since 11 and 12 are near each other, that's all the factors. So if you want to get factors of a number, you just take that number and divide by x. So all these are my factors. The only ones that subtract and get a 1 are 12 and 11. Now check this out. The larger factor will have the same sign as the middle number. So the 12's got to be positive and the 11 negative. Now check yourself. 12 minus 11 equals 1. 12 times negative 11 equals negative 132. All right, so now set your factors equal to 0. So here, I'm going to subtract 12. And I get x is a negative 12. Well, y'all, that's what the calculator told me. And then here I would what? Add 11 and get x equals 11. So if you like factoring, this is the way to go. But remember, at this point, I can put this into y equals and look for those x-intercepts that way, okay? All righty. So my rational zeros, because it's going to have you put rational zeros and then other zeros. Well, the other zeros would be stuff like the imaginary stuff and the radicals. Since these three numbers I found, 1, negative 12, and 11, they're all considered rational zeros. Okay, the only ones that ain't, like I said, are the I and the square root stuff. Now it says linear factors. So they'll have the f of x here. What we got to do is put all three of these zeros in parentheses. But remember, when I write them as factors, the 1 will be minus 1. The factors always have opposite signs than the zeros. And then that one was negative 12, so this will be x plus 12. That was a positive 11, so this will be x minus 11. Right, here's the factors we had when we found the zeros. So notice how the 12's positive and 11's negative. All right, y'all, so that's what they're doing on that one. All right, so I'm going to do one more of those. Let me see. I think I'll do one like 17 here. And y'all, it's the same directions. So 17, they're giving us f of x equals 5x to the third plus 7x squared plus 245x plus 343. So what we're going to want to do on that is find at least one of those zeros. So I'm going to go try to graph that and see if I can find any zeros, okay? So we'll go to our calculator. Now this one this might be the one where I got to show y'all a trick. All right, 5x to the third. Arrow down, I got what next? 7x squared. Plus 245x plus 343. All right, so I got it in. I'm going to go to graph and see what I get. Oh, y'all, let me go back. So remember, to go back to a regular graph, you hit zoom 6 for zoom standard. That'll put it back on a 10 by 10, okay? Now notice, that looks like it's going in between the 1 and the 2 on the negative side. And if I go to my table and I go to my -1, notice I don't get a 0 there. So let me tell you why, because this one's going to end up as a fraction. So what you want to do is go to your, see this where it says window, you're going to hit second window for table set. Now, I'm going to go down here to where it says that triangle table. That means what do we want to change in our table to be? So y'all, here's what you're going to do. You're going to go 1 divided by, the first number of the polynomial was a 5. So we're going to do 1 divided by 5. If you start out with a 7x to the third, you'll do 1 divided by 7. We need the table to change by a fraction that matches the first number on your polynomial. Now watch when I go to second graph. Right there at that -1.4, I got a 0. So I'm going to write -1.4 because that's going to be the first one I check. But check this out. I'm going to quit this screen and I'm going to see what -1.4 is when I turn that into a fraction. I'm going to hit math and enter twice. And a -1.4 is a -7/5. Because let me see, I think Math Lab is picky and they want fractions on that. So let me look. Yeah, it says use integers or fractions. So we cannot use decimals on that. So we got a -7/5. So let's go back. So a -7/5 will be my first 0. Alrighty. So let's write our numbers down. We got a 5, 7, 245, and 343. All right, y'all, so here we go. The 5 comes straight down. Five times -7/5. Remember, -7/5 times 5. Them 5s cancel, and you end up with a -7. 7 and -7, give me a 0. 0 times -7/5 is 0. All right, y'all. 245 and 0. Give me 245. So now we got to multiply that -7/5 times 245. So it'll give me a negative something. So guess what? We got a calculator. So y'all, we had -7/5. So -7 divided by 5. And we're going to multiply that by 245. So let's hit enter. We get a -343. Well, y'all, guess what? We had to get a -343 there, because if we got the right zero, then that remainder had to be 0.
Yeah.
Okay. So remember what we got here. This is now an x squared, since it started out with an x to the third. So this is 5x squared plus 0x plus 245. I'm going to set that equal to 0. All right, so I don't have the x term in the middle, so this one I don't have to try to factor. This one I'm going to do square roots. So I'm going to subtract 245. So y'all, you get your 5x squared. It'll equal a -245. And before we do square roots, we're going to divide that 5 off both sides, okay? So that I got my x squared all by itself. All right, y'all, let's see. What do we got? -245 divided by 5. So that's what? 20, 40, 49. So that'll be a -49. All right, y'all, so I'm about to test y'all on something. I'm going to take square roots of both sides. So this will be a plus or minus square root of -49. So those cancel, giving us our x. This will be a plus or minus. So y'all, the question on y'all would be, what's the square root of that -49? All right, let me see, my chat's lighting up. Oh, y'all are so close. It is 7, but remember that's negative under that radical. So what did we do when it was negative? So Jalen and them got part of it right. Nancy, you got the other part right. So 7i, there you go. So that would be a plus or minus 7i. So remember, take the square root, and since it's negative, bring out that I, okay? All righty, so we got a -7/5, 7i. So this one will be different now. Watch this. The rational zeros, the only rational zero we got was the -7/5. Then the other zeros, remember we said that the imaginary would be the other zeros. So that'll be your 7i and your -7i. All right, then it wants linear factors. So f of x equals, so 3 zeros means 3 parentheses. So since that was a -7/5, that'll be a +7/5. That was positive 7i. It'll be -7i. And that was -7i. It'll be +7i. Now, y'all, here's the thing on this one. MathLab don't like this fraction here. So what we got to do is take that 5 and put it out front, so that we get 5 times x plus 7, x minus 7i, and x plus 7i. This the one thing about MathLab I didn't like on this problem, is that you had to split your fraction up. But yeah, whatever fraction you get here, bring the bottom of it out to the front, okay? And then this would be what you put. So, y'all, 16, 17, and 18. Sort of tricky, but get the first 0 or 2 by graphing that stuff, okay? And then once you get it down to your 3 numbers, figure out how to either graph that like we did or solve it using the quadratic stuff. All righty, y'all. So next, I'm going to do 5.1 support. All righty. So 5.1 support, all they want you to do is factor. But they're going to hit us with different types of factoring, okay? So I'm going to show you ways that I would factor some of these. So the first one, you're getting a 10x squared plus 5x. So when I got two terms being added, all you can do to this here, all we can do is factor out a GCF. Sort of like we did when we was doing them 4-term factoring the other day. So I would ask y'all, what do these two things got in common? What's the greatest factor they got in common? All right, chat, let's see what you got. So 5x, good job. Good job. So the 10 and 5 had a 5, and the x squared and x both had an x. So now what you do, you divide both of these by 5x, and it goes into parentheses. So 10 divided by 5 is 2. X squared divided by x leaves you 1x plus, and that 5x divided by 5x is a 1. Then y'all, you can't go no further on that one. So for the first one, and even this second one, watch this. You got an r to the 5th plus 10r to the 4th. These two things are being added again. So y'all, once again, factor out a GCF. What does the R5 and R10, R4 got in common?
You said, what does the...
What's the greatest common factor between them two right there?
Oh, that they both got... I was about to say R, but I think I'm wrong.
Oh, they both got an R, but how many? How many do they got in common? And let's see. Yeah, Nancy's got it on there, and Samantha looks like 2. So you always go with the smallest exponent, so they both had at least R4.
Okay.
Now, you divide an R4 from R5, that's going to leave me 1R plus the 10R4 divided by R4. The R4s cancel and leave me my 10. So this, when you factor out a GCF, it's undoing your distributive property. And what's left in the parentheses can't have nothing else in common, okay? Other than a 1. So we're as far as we can go on that. Now let's, some of this stuff I'm about to factor. Watch this. T squared plus 14t plus 48. Now, watch what I do. These trinomials like this will factor into 2 parentheses. In the front is a t squared, so the only way to get a t squared would be a t times a t. Now, this plus sign in front of that 48 tells me 2 things. The first thing it tells me is my factors got like signs. So the plus means my factors got like signs, and they'll both be like the middle number. So they'll both be positive. Now, the plus also tells me to find factors of 48 that add to get 14. And look, ooh, Samantha, you already got them, 8 and 6. 8 plus 6 is 14. 8 times 6 is 48. Good job. Now remember, if you didn't know the factors of 48, you can go to y equals and do 48 divided by x, and then look on your table. It'll give you all the numbers, okay? And y'all watch this. I'll put you a chart over here. So both signs are positive, both factors will be positive. If the last one's positive and the middle negative, they'll both be negative. Now, since that's plus at the end, I would find factors of the last number that added to get the middle numbers on those, okay? All right, so y'all watch this. V squared minus 5v plus 6. Well, that's another trinomial. We're going to factor into parentheses, and there's no greatest common factor on that because there's not a v here or a number here. So the v squared would be a v and a v. All right. Remember, that last sign being positive tells me both factors will be negative like the middle, just like we got right here. So both of those will be negative. All right, what factors of 6 equal 5? And good job, that'll be 2 and 3. Now, 6 times 1 will subtract to get 5, but we needed the two factors of 6 that added to get 5, so that'd be 2 and 3. All right, r squared minus 28 minus 3r. All right, this one is not ready to be done anything to because it's out of order. So this one needs to be rearranged. So bring down your r squared, then your negative 3r minus your 28. So now we're in order. We got an r squared, so that'll be an r and an r. So y'all, here's the patterns when it's negative at the end. So x squared plus x minus c. Well, one will be positive, one will be negative. The larger factor is positive. So what if they're all negative? Well, that last one's still negative, so you got one of each sign. But the difference this time is, since it's negative in the middle, the larger factor will be negative. So if the middle's positive, the end's negative, the larger factor is positive. Negative in the middle, negative at the end, larger factor is negative. Now, also remember, since that's negative, I want factors of 28 that subtract to get 3. Also, Matthew, you got them, negative 7 and 4. So the 7's bigger, we're going to make it negative. And then the 4 is positive. And you ought to make sure negative 7 plus 4 gives you negative 3. And then if you multiply those, you get a negative 28, okay? All righty, so let me do one more like 6, because number 7 is pretty much like this one. So I'm going to do one more. 4y squared minus 16y plus 16. So y'all, I'm going to do one thing before I factor this. Because guess what? All three of these numbers have. This one has a greatest common factor. So first, I'm going to factor out the GCF. So a 4, 16, and 4, what's their greatest common factor? So divide all by 4. There you go. So we're going to bring out our 4. 4 divided by 4 makes that a y squared. Minus 16 divided by 4 gives me a 4y. Plus 16 divided by 4 is a 4. And then we got to factor the parentheses. So bring down your 4 and make your parentheses. So the y squared would make a y and a y. All right, the last number is positive. So when the last number was positive a while ago, in the middle was negative, we said they would both be negative. Because remember, they got to be like signs. So like signs are both like the middle. All right, what factors of 4 add to get 4?
What factors of 4 add to get 4?
Uh-huh.
2.
Uh-huh. So that would both be a 2, right? So we got a y minus 2, y minus 2. Now, this would be the answer, but this one can be written in shorthand also. So if you want to, you can put 4 times y minus 2. And since there's 2 exact factors, we can make that a y minus 2 squared. So you can write it out the long way or shorthand on that one, and it will take it either way. So support was really getting you ready to factor because 5.1 has problems where we're going to have to do some factoring, okay? So y'all keep hold of those for your signs, okay? They're like this 100%. So these 2 patterns and these 2, keep those, okay? And let's get into 5.1. Now this 5.1 college algebra don't have a lot of problems. I think there's like 5 or 6. So 5.1, rational expressions. So that means fractions again. Now this stuff is a repeat of stuff we did earlier. The only difference is on the bottom of the fractions, some of them they're going to put some x squareds and stuff like that, okay? Now, it's going to start out with 2 questions that say find all numbers for which the rational expression is not defined. So 1 and 2 will be the same type problems. So y'all, number 1, they're giving me 6c squared minus 10 over 9c plus 25. Now, y'all, we did this kind of problem on test 2. I think we did the domain stuff. No. Test 1, we did domain stuff. So here's the thing. What'll make this fraction undefined is if the bottom equals 0. So if I want to find numbers that make it not defined, I'm going to take the bottom, 9c plus 25, and I'm going to set it not equal to 0. So the not equals and the equals, we'll work this the same way we would if that was just equals, okay? Now, we're not worried about the top. We're only concerned with the denominator, just like when y'all did the domains on the fractions. So to solve this one for C, since it's not squared, I'm going to subtract my 25 first. So this is saying that 9C cannot equal a negative 25. Well, that makes sense. If this is 25, this can't equal negative 25 because that makes it equal 0. So now let's actually solve for the C by dividing by 9. So that cancels. I got C cannot equal. Well, I can't do nothing to that. So that's going to stay a negative 25th over 9. So MATLAB will say the rational expression is not defined for C equals, for C not equal to a negative 25 over 9. And y'all, let me look at one thing on that real quick, see how they're doing their answers in MATLAB. Yeah, you just put in the answer in the blank on A, okay? So that one would have been like an earlier one, but this second one, watch this. Z squared minus Z minus 5 over Z squared minus 16Z plus 63. And y'all, you don't even have to put the equals on this and just a number. So this one, same thing. Take the bottom. And we know that that cannot equal 0. Now, this is a Z squared, so we're going to have to factor it. So Z squared will be a Z and a Z. Last number's positive, so both factors will be negative like the middle. So I'm still following those patterns I gave you. So all I need now are factors of 63 that'll add to get a 16. So what do you get? 9 and 7. Good job. All right, so I got my two factors, set both of them not equal to my 0. And y'all, all we're doing now is changing our signs, remember? So add 9. So Z cannot equal 9. Over here, add 7. So Z cannot equal a positive 7. So MATLAB, the rational expression is not defined for Z equals 7 and 9, okay? All right, so what they was doing was just doing these problems to get you back in the habit of finding domains. And because on a domain, that's what I'm doing. I'm setting the bottom equal to the 0 and getting my numbers. So y'all watch this. Find the domain. Write both set builder and interval notation. All right, so these would start, let's see, about number 3. All right, y'all, f of x equals 5 over 2x minus x squared. So I now got to take my denominator, because remember, the only thing we're worried about in a domain is a fraction. What'd y'all say? And I'm going to set that not equal to 0. So y'all, let me ask you this. We just factored that support stuff. The first two problems, I factored out a GCF. What, do y'all see a GCF on these two? What's the greatest common factor between a 2x and an x squared? Okay, I'm going to go with the x. Remember, it can't be a 2 because the second one didn't have a 2 in front. So both of them did have an x. So if you factor out an x, what would y'all put inside the parentheses then? So y'all 2x divided by x, that x cancels, and you get a 2 minus, and then you had an x squared, you divided out one of the x, is going to leave 1x. All right, it's now factored, so set both factors equal to 0. Or not equal, how about that? So this one's done. Remember, anytime you get a single variable, it always equals 0. Now here, I'm going to solve that. So y'all, the easiest thing to do to this one would be just to add that x. So I get my 2 cannot equal my x. Now you could have subtracted 2 and then divided by -1 and you'd have got the same answer. So let me show you. Set builder notation. They're going to give you the x such that x is a real number. And then they'll put an and x not equal to, and then you put in your two numbers. So we got what, a 0 and a 2. So they'll give you the option, you pick the one with the not equals, okay? Now interval notation will be a little different. Remember, interval notation started at -infinity, and then we got a union around each of the numbers we're kicking out, and they got to go in order left to right. So 0 would be first. Union around that 0 to kick it out. From 0, you're going down to x's till you hit the 2. So we're going to union around that 2 to kick it out. So both of my numbers are kicked out. So now my domain can head off towards positive infinity. So they all will start at -infinity and end at positive infinity. And if you got two numbers, you got to do two unions to them, okay? So y'all, are not too bad. You just got to get used to kicking them numbers out in that interval, okay? So let me let y'all catch up just a second, and then we'll do some one more of those. And I'm glad this stuff is sort of a repeat of earlier as far as finding the domain. It's just that they're throwing these x squareds at you now, okay? All right, y'all, so let's see. Camera back up. So one more of these. Oh, this one will be like number 4 or 5, I think. Can't remember. I'll just call it 4. All right, y'all. F of x equals. So the top is the x to the third minus the x squared plus the x plus 4. But y'all, we don't care what's on top. All we're worried about is the bottom, which is the x squared plus 11x plus 28. So I know my bottom cannot equal 0. So let's bring that down and set it not equal to 0. Now you can use equals here. The reason I'm using the not equals is so y'all remember in set builder notation, you got to pick the not equal stuff, okay? All right, y'all, that's an x squared, so that's an x and an x. So what I want y'all to give me is the two numbers. Oh, hell, you done got them, Samantha. What factors of 28 that'll add to 11 are going to be 7 and 4. And since that's positive, they're both going to be positive like the middle. So good job. So now all we're doing is setting them to 0 so we can change their signs. So y'all, both of these will end up negative. I'll get a x cannot equal a negative 7. And then here we'll subtract 4. And x cannot equal a negative 4. So set builder. Now, y'all, this one's picky. They want this one in ascending order. So x such that x is real and x cannot equal blank and x cannot equal blank. And under it, it says ascending order. That means they want the smallest number first and then the next. So between negative 7 and 4, negative 7 is smaller. So you got to put it first and then your negative 4. And the reason they're doing that is so you get it right on your interval notation. Because a lot of people have trouble with the negative numbers. But remember, the bigger the negative, the smaller. All right, so y'all, let's see. Starting at negative infinity for my interval notation until I hit negative 7. I'm going to kick out negative 7 by unioning around it. From negative 7, we're cruising until we get to negative 4. So we're going to union around negative 4 to kick it out. And then we're off towards positive infinity. All right, y'all, so that's what you're doing in 5.1. So I'm going to do one more thing with you. 8.5 support. That way, next class, we can do 8.5 and 8.6. 8.6 is pretty small. 8.5 will be the longer one of those. Now, the reason I went on and did 8.5 because it's a lot of factoring. Watch what this says. It says simplify by removing factors of 1. What that means is if you get a factor on top that matches the factor on the bottom, we can cancel them out, and that'd be like canceling out a 1, okay? So there's 3 of these is all. So 5y minus 30 over 5y plus 30. So these two terms up here, both of these are all 2 terms. What you're going to do is factor out GCS from those. On top and bottom. So what's the top got in common? That 5y and that 30. So they both got a 5. Good job. So you would factor out your 5 and make that a y minus 6. So 5y divided by 5 left my y. 30 divided by 5 left my 6. Well, guess what? The bottom is exactly the same other than the sign. So that GCF will also be a 5. But that's going to leave me a y plus 6. So y'all, here's what they mean by removing factors of 1. 5 divided by 5 equals 1. So I'm canceling that out. So now, since I only got these left, I don't need parentheses. So I get a y minus 6 over a y plus 6. Now listen, you cannot cancel the y out. The only way you can cancel these y's out is if both of these matched up perfectly. Since y is not a GCF like this, you can't cancel it out, okay? We can only cancel out factors, not terms. All right, y'all, watch this one. P squared minus 25 over P squared minus 10P plus 25. So notice, you got two terms here, but they don't have a GCF. So this means that this is the difference of perfect squares. They're going to factor into conjugate pairs. So y'all watch this. P squared will be a P and a P. So remember, these are the difference of perfect squares. All right, the last number is negative, so that means one's positive, one's negative. And to finish this out, what's the square root of 25? So 5, so we would put a 5 and a 5. See, if you added them, 5 and negative 5 give you 0. Well, there's not a P in the middle, so it would be 0. And then 5 times negative 5 give you that negative 25. All right, y'all, the bottom is a trinomial. We know it's going to factor into parentheses. P squared will be a P and a P. Last one's positive, so both factors will be negative like the middle. So what factors of 25 add to get me a 10? And I guess we only got 2 guesses on that, right? So let's see.
It's
That 5, yeah, because that'd be what, a 5 and a 5. So negative 5 and negative 5 give me negative 10. Negative 5 times negative 5 give me 25. But y'all look at that. This P minus 5 will cancel out with one of these P minus 5s. So my final answer is a P plus 5 over P minus 5. All right, y'all. So the last one was just factoring. It wasn't a tricky one. It was just 2 trinomials. I'm going to let y'all try that and see what y'all do. But it'll have factors canceling it out like this. So if you notice, the moral of the story, once we got out of 8.4, was a lot of factoring, okay? All right, y'all, and guess what? That'll get us ready for 8.5 come Thursday. And let me see something real quick here. Oh, so 8.5, we'll be learning some new words like vertical asymptotes, horizontal asymptotes, and all that fun stuff. Now, I do want y'all to remember on 8.4, I want y'all to skip what was them 2 numbers. Let me find them. I think it was 13 and 14, but I'm not sure. Skip 14.
Wow.
So you're
So
skipping.
when did I have these
14.
children and leave them there? Those are just absolute rumors.
So right here on the packaging, the kids are not.
All right, y'all. So you're skipping 14 and 15 in 8.4. I will go in there later tonight and I'm going to give y'all credit for them too. That stuff, that's ancient news on that kind of stuff. And what we did with graphing the calculator is the best way to do those, okay? So that was supposed to be taken out of our homework, but they forgot to do that. So skip them two. I will go in and override those two for everybody, okay? All right, y'all, that's all I got for us tonight. So 8.4 and 5.1 college algebra, okay? And then that was the support in between. So I'm going to
Sounds
stop
good.
share.